Hi, you guys. I'm going to try to go over 6.4. Take notes as possible and watch this as many times as you need. Now, first thing to remember, exponential graphs and logarithmic graphs are inverses, so they're reflections across y equals x. As you can see, I have the exponential shapes in light blue. You can immediately tell that a and f are exponentials. Same thing with the log functions. The parent function always looks like that, so you can match d and e. Now the other ones are reflections, and you should be able to also tell those too, but for right now, those are our examples. Okay, so on to the next page, you'll see that we have the same translations that we've been using all year. The horizontal translations are going to affect your horizontal movement, right and left. Okay, so if it's with the x, it's going to go right or left. The vertical translation is like your y on the end, so that's going to be up and down. A reflection, of course, is going to be over a line. So it's going to basically change all of your y's if it's on the outside, which is a reflection in the x, and it's going to change all your x's if it's a reflection in the y. The shrinks, again, we're going to have horizontal and vertical. Just remember, the vertical ones are going to stretch or shrink by whatever that a value is. Okay, so it's very straightforward. It's just a times the function. But the horizontal stretch is a little bit different because, as you know, it's going to be affecting the x's, and it will shrink them oppositely. So if it says 2x, it'll be a shrink factor of a half. If it says a half x, it'll be a shrink factor of 2. So once we do those, take a look in your book and look at all the translations. For instance, example 1, the blue is the parent function and the red is the transformation. Moving on to the next page. Okay, logarithmic functions are almost exactly the same. The only difference is exponentials, right, as they go to the right, get huge, and logs as they go to the right approaches an asymptote. So it's just a matter of starting with a different parent function. Same exact things here. Write them in your notes. Keep them close. If we go to the next page, you'll see some examples where we're actually going to write the functions. Okay, so as you can see, we're going to start with an exponential on example 5. Then we're going to do a logarithmic in example 6. So I figure at this point, I'll just start doing examples and walk through it, and then we'll try some problems together. So my first example will be if the function f of x equals 3 to the x is reflected in x, then we can write g of x equals the opposite of f of x. At this point, we're going to substitute f of x. And if I want to do another transformation, say translate to left, then I can write that h of x is equal to g of x plus 2, because that's the transformation that will move it left. And again, I'm going to substitute g of x. I'm going to write x plus 2 where there is an x to finally get h of x equals the opposite of 3 to the x plus 2 power. So for my second example, now I have a log function, log base 1/6 of x. If I'm going to translate it one down, remember you're going to move your y's. That's a vertical shift. And all I'm basically going to do is do f of x minus 1. So whatever f of x is, which I'm circling, it goes right there, and you take away a 1. Now I want to do a vertical stretch of, let's say, factor of 5, then my new function h of x is going to be 5 times g of x. So if I have g of x, that's going to go right here, and everything in g of x is going to get multiplied by 5, so it looks like this. And I distribute to get h of x equals 5 log base 1/6 of x minus 5. So that's the section 6.4. Here's your assignment. There are 12 problems we would like you to go through and do your best on. Of course, if it's odd, you can check it in the back. Otherwise, do your best. And I've attached the pages to this education as well as a little quiz on 6.1 to 6.4 if you want to see how you're doing. It's also in your book, and I look forward to talking to you guys later. Okay? Best of luck. Stay healthy.